Hi everyone, welcome to this complete walkthrough of Edexcel AS Pure Mathematics Paper 1 of 2018. Just so you know, Edexcel revised the specification extensively in the teaching years 2017, and therefore 2018 is the first official assessment of the new specification. Therefore, it will be a very good practice for students who are moving from GCSE to AS level to start practicing with the 2018 past papers. In this walkthrough, I have taken efforts to make the presentation in the same way as expected for you to do in the exam. So let's start with the first question. Find integration of this. So first and foremost, we should check whether the expression is written in an integratable format. Otherwise, we need to change. So let's write this as equal to integral 2/3 x to the power of 3 minus 6 x to the power of half plus 1 dx. Integrating this, we get 2/3 x to the power of 4 over 4 minus 6 x to the power of half plus 1 is 3 over 2. And then I need to divide this by 3 over 2, which is equivalent to multiplying by 2 over 3 by flipping the denominator, plus x. And what more should I write? Plus a constant c. What's remaining is we need to write the answer in the simplest form. Therefore, simplifying this, we get 2 goes into 4 2 times, so this x to the power of 4 over 3 minus 6 times 2, 12 divided by 3 is 4, x to the power of 3 over 2 plus x plus c. That's it. Just a sec. So here it is going to be 6. Question 2. Show that x squared minus 8x plus 17 is greater than 0 for all real values of x. So in order to show that this is greater than 0, we need to say that this is positive. It cannot be negative. That means completing the square is the best way. So let's write x minus 4 to the power of 2 minus 16 plus 17. Okay, this is equal to x minus 4 square plus 1. Then we could write this part being a square is always positive. Okay, this part plus 1 is also positive. Therefore, overall, the expression is positive. Is greater than 0. Second part. If I add 3 to a number and square the sum, the result is greater than the square of the original number. State giving a reason if the above statement is always true, sometimes true, or never true. So we need to put this test. What is it? If I add 3 to a number, let's say x is a number, and I put plus 3 here and square this. Okay, so what do we get? I'll get x squared plus 6x plus 9. Okay, so in most occasions, this must be greater than x squared. So can we figure out when will this be not true? Okay, because this is something added to this x squared, so it will be greater than the original square. Suppose I put x is equal to a minus number, for example, minus 5, then this will become minus 5 plus 3 square will be equal to minus 2 square, which is equal to 4, which is obviously less than square of minus 5, which is 25. Therefore, this is only sometimes true. Therefore, it is only sometimes true. Question 3. Given that a point A has position vector 4i minus 5j and the point B has position vector minus 5i minus 2j, find the vector AB. So in such questions, it's better to draw a small sketch, even though it's not very accurate sketch, so that we know what's going on. Okay, so point A is 4i, so 4 across, and minus 5 means down 5. So let's say this here. A 4i minus 5j. Okay, and the point B has position vector. Always it's with reference to the origin. Okay, so minus 5i across minus 5 and down minus 2. So it's going to be B here. Minus 5i minus 2j. And then these are the vectors, position vectors. Okay. Let's also draw these arrows. Okay. Always it is from the origin O. Okay. The question is asking us to find what is vector AB. So let's put this arrow here. So in order to reach B from A, suppose we go from A to O, it will become what? Minus of this 4i minus 5j. So minus bracket 4i minus 5j plus minus 5i minus 2j. If you simplify this, we get it. So minus 4i plus 5j minus 5i minus 2j. Okay, simplifying, collect all the i's together and the j's together. Minus 4 and minus 5 will make it minus 9i. Okay, plus 5 minus 2j is plus 3j. That's it. Then find vector modulus of vector AB. So B is modulus of vector AB. This is just nothing but the Pythagorean value of this. That is, we need to put this as square root of minus 9 square plus 3 square, which simplifies to square root of 81 plus 9 is equal to square root of 90. Okay. Look back at the question, give your answer as a simplified third. So you need to simplify this as a third. So what is the biggest square hiding inside 90? It's 9. So we can write this as 9 times 10 inside, which will simplify to 3 square root of 10. That's it. Question 4. The line L1 has equation 4y minus 3x is equal to 10. Line L2 passes through these 2 points. Determine with giving full reasons for your answer whether L1 and L2 are parallel, perpendicular, or neither. So our strategy should be to find the gradients of these 2 points, and then we can decide whether they are parallel or not. So starting with 4y minus 3x is equal to 10, which should be rewritten so that y becomes the subject. So 4y is equal to 10 add 3x. Okay, dividing by 4, y is equal to 10 over 4 plus 3/4 x. So then you write, therefore, gradient of L, gradient of line L1 is equal to 3/4. Okay, so park it there. Let's figure out what's the gradient of L2. There are 2 points here, 5 minus 1. I could make some space here. The gradient of L2 equal to, our classic method of finding out the gradient is y2 minus y1. So 8 minus minus 1 over minus 1 minus 5, which makes it 9 over minus 6, which is equal to what? So 3 goes 3 times there. So 3 over 2, and the minus sign will go to the numerator. Okay, so this is the gradient of the second line. So is there any relationship between the gradient of the first line and the second line? If they were parallel, they should be equal. So they are not equal. So they are not parallel. If they were perpendicular, one should be a negative reciprocal of the other. That's also not true. So we can say, as they are not, we can say, as the gradients are not equal, as the gradients aren't equal or negative reciprocal of one another, okay, comma, the lines are not parallel nor perpendicular. We need to write this statement to get the full marks. Question 5. A student's attempt to solve the equation 2 log x to the base 2 minus log square root of x to the base 2 is equal to 3 is shown below. All right. What's the question? Identify 2 errors made by the student, giving a brief explanation of each. All right. So we need to go through these statements made by the student and check out for 2 errors. Let's look at the first step. This is okay. That's just rewriting the question. Second, this is incorrect because before he does the subtraction rule or division rule here, the subtraction converting into division, he should have put the coefficient as the square of x. So the coefficient is not converted into an index. That's the first error. Okay. Second part, let's see. This okay. This is okay. So here he has put the 2 here. He has squared the square root of x, so it became x here. So that's fine. The next step here is an inaccuracy there. What has happened is he has put x is equal to 3 square, which is not correct. Actually, log x to the base 2 is equal to 3 means x should be equal to 2 to the power of 3, not 3 to the power of 2. So that's the second error. So let's document both the mistakes here. The first mistake, the student has used subtraction rule of logarithms before changing the subject, changing the coefficient. Coefficient of logarithm to power. That's the first mirror. So one, I. The second one was the student has undone the logarithm. Undone means remove the logarithm and written in the normal form. Undone the log incorrectly. Okay. Log x to the base 2 is equal to 3 means x is equal to 2 to the power of 3. Well, second part, write out the correct solution. So we need to correctly solve the question now. So writing out the equation once again, 2 log x to the base 2 minus log x to the power of half to the base 2 is equal to 3. That's the original equation. So let's convert this into power form. Log x square to the base 2 minus log x to the power of half to the base 2 is equal to 3. So doing the division rule here now. So log x square over x to the power of half to the base 2 is equal to 3, which means log x to the power of 2 minus half is 3 over 2 is equal to 3, which means here, of course, that 2 is there. Okay? So x to the power of 3 over 2 is equal to 2 cubed, which is equal to 8. Therefore, x to the power of 3 over 2 is equal to 8. So in order to remove this 2 in the denominator of the index, which means a square root, we need to square both sides. So you could say squaring both sides, we said x cubed is equal to square of 8 is 64. So next is x should be equal to cube root of 64, which is equal to 4. That's it. Question 6. P is equal to 100 minus 6.25 bracket x minus 9 whole square is this curve. All right. A company makes a particular type of children's toy. The annual profit made by the company is modeled by this equation, where P is the profit measured in thousands of pounds. Please underline this because it will be quite useful for us to convert the answer into the profit value. And X is the selling price of the toy in pounds. Okay, so here it is just in pounds. A sketch of P against X is shown in the figure. Using the model, explain why £15 is not a sensible selling price for the toy. So what we need to do is put this X value as 15 in this equation, and then it will throw up something which is not correct. So that's what we have to identify. So let's try that. So putting X is equal to £15, profit is equal to 100 minus 6.25. I'm just repeating the equation with X being replaced by 15 minus 9 square, which is equal to 100 minus 6.25 times 6 square, and putting it into the calculator, I get this as minus 125. Obviously, if profit is minus 125, it means it's a big loss for the company for each toy. Therefore, the company will be making a loss. So we need to say that X is equal to £15 is not sensible. As the company will be making a loss. This £125 loss is for the number of toys sold by the company overall. Each toy is selling price £15, ends up as a total loss of 125 for the company. Therefore, it's not a sensible price. Given that the company made an annual profit of more than £80,000, find, according to the model, the least possible selling price for the toy. So here what we need to write is £80. We should not write 80,000. £80 is equal to 100 minus 6.25 bracket X minus 9 whole square. So this is rewriting the model with profit equal to £80,000. So if we solve this, we will be finding out the value of X, which is what the question is asking. So rewriting this in a way that is convenient to us, we can say 6.25 bracket X minus 9 whole square is equal to 100 take away 80, right? Therefore, X minus 9 square is equal to 20 upon 6.25. Okay. Next is X minus 9, taking square root on both sides, we should be writing plus or minus square root of 20 over 6.25, okay, which translates to X is equal to 9 plus square root of 20 over 6.25, or 9 minus square root of 20 over 6.25. Putting this into the calculator, we get the value as pounds 10.79 one price, or the second price is pounds 7.21. As the question is asking, what's the least possible price? So we need to write this one. Therefore, the least possible price, least SP for one toy, is equal to pounds 7.21. Next part of the question. The company wishes to maximize its annual profit. State, according to the model CI, the maximum possible annual profit, and II, the selling price of the toy that maximizes this annual profit. So to find the maximum possible profit, what we need to write is, let's say P is equal to 100 minus 6.25 bracket X minus 9 square, rewriting the model. Okay, so if P should be the max, let's say P max, that will be 100 minus 0, because this is always taken away from 100. 6.25 is positive, X minus 9 whole square is no way negative. That means this whole thing is positive, being taken away from 100. So only if this is 0, the profit will be the maximum. So that is equal to 100. So which can be written as 100,000. That's the maximum profit that the company can aim to achieve. The next part of the question is, at what selling price will this maximum profit be achieved? So we need to write this as when x minus 9 whole square is equal to 0. X is equal to 9. So therefore, that price will be £9. Question 7. In a triangle ABC, side AB has length 10 centimeters, side AC has length 5 centimeters, and angle BAC is equal to theta, where theta is measured in degrees. The area of triangle ABC is 15 centimeters square. Find the two possible values of cos theta. So please analyze the information given in the question and devise a strategy. It's giving you the dimensions of a triangle with angle also, and it's telling you the area, which actually can be useful to find sine theta. And then it's asking for the values of cos theta, which means we need to first find sine theta, and then from that derive the value of the cos theta. That will be a good strategy. So let's work it out. So A. So in order to start, it's better to sketch this diagram. So let this be a triangle. Okay, it's not a right angle triangle. Just draw any scalene triangle. Okay. Let's say this is A, B, and C. Okay, angle BAC is theta. Side AB has length 10 centi, and AC has length 5 centimeters. Okay, and BC is not given. All right, but we have been told that the area of this triangle is 15 centimeters square. So straight away use the area formula for the triangle, which is area of a triangle is equal to half AB sine C. Okay, so that is 15 centimeters is equal to half times A is equal to 10 here, B is equal to 5 here, and sine of the angle in between is sine theta. So from this, we should be able to derive the value of sine theta. So 15 is equal to 25 sine theta, which means sine theta is equal to 15 over 25, which simplifies to 3 over 5. Okay, so in order to get the value of cos theta from here, what we need to do is draw a right angle triangle. Okay, and then say this is theta. Okay, if sine theta is 3 over 5, opposite side should be 3 and hypotenuse should be 5. In that case, this side should be 4 because it's a Pythagorean triplet now. 25 minus 9 is 16, square rooted is 4. Okay, so that means cos theta will be equal to plus or minus, because it can be two values here, 4 over 5. Okay, I'll show you why there can be two values. So sine theta is 3 over 5, right? So suppose we draw the 4 quadrants diagram here. Okay, so sine is positive in this quadrant and in this quadrant. If it is 3 over 5, that means the sine theta is in these two quadrants. Okay, so theta is here, theta is here. Since we can't change the angle, so cos theta also should be based on these theta values, right? So cos theta is positive here, but cos theta is negative in this quadrant. That's why we are writing positive is 4 over 5 here and negative is minus 4 over 5 here. Okay, so we need to do what next? Find the two possible values of cos theta. That's done. So we can just finish this answer like that. And second part of the question is, given that BC is the longest side of the triangle, find the exact length of BC. BC is the longest side of the triangle. Okay, so that means BC is the longest side. Means the angle opposite to the longest side must be the biggest angle. So therefore, angle BAC is obtuse. Obtuse means it is between 90 degrees and 180 degrees. So it falls in this quadrant. Obviously, cos must be minus 4 over 5 now. Therefore, cos theta is equal to minus 4 over 5. And the question is asking you to find the value of theta, right? Find the exact length of BC. Okay, so since we know cos theta here, we don't need to solve for theta. We just need to use the cosine rule. What's the cosine rule? A square is equal to b square plus c square minus 2bc cos angle A. Okay, right. So let's use that one. So bc square is equal to 10 square plus 5 square minus 2 bracket 10 bracket 5 cos angle theta is minus 4 over 5. Okay. Which simplifies to 100 plus 25 minus 20 times 5 is what? 100 times minus 4 over 5. Putting this into the calculator, I get 205. So BC square is 205. Therefore, BC is equal to square root of 205. Since the question says find the exact value of BC, don't attempt to put this into the calculator and convert into decimals. Just write square root of 205. You can write square root of 205 centimeters. Question 8. A lorry is driven between London and Newcastle. In a simple model, the cost of the journey in pounds C. When the lorry is driven at a steady speed of v kilometers per hour is this model. Okay. A. Find according to this model the value of v that minimizes the cost of the journey. So remember, if it says minimizes, it could mean we find dc by dv and put that equal to 0. Solve for that value of v when dc by dv is equal to 0, and then that's the answer for that question, and then put that value into c. That will be the answer for the next question. So let's try that. So question A. So let's write the model first. C is equal to 1500. V in the denominator becomes v to the power of minus 1 plus 2 over 11 v plus 60. Okay, so differentiating this with respect to v, so we write dc over dv is equal to minus 1500 v to the power of minus 1 is minus 2 plus 2 over 11. Differentiating v, we don't get anything, it is just 1, plus 60 becomes a 0. So this is equal to 0 when c is the minimum. Therefore, we can now write this plus this is equal to 0 means 2 over 11 should be equal to 1500 v to the power of minus 2. Because one is minus and the other is plus and they net off to 0, that means the two positive values should be equal to each other. So which actually translates to 1500 over v square is equal to 2 over 11. So flipping, we can say v square over 1500 is equal to 11 over 2. From that, make v square the subject and solve for it. So 11 over 2 times 1500. Okay, that gives us a value of, so v square is equal to 8250 and v is equal to 90.83. Since it's velocity, it's meters. Is it kilometers per hour? Kilometers per hour. Next is to find what is that minimum value of c when we apply v is equal to 90.83 in that model. So let's write that out. So c equal to, c minimum is equal to 1500 bracket 90.83 to the power of minus 1 plus 2 over 11, 90.83 plus 60. Okay, putting that into the calculator, I get pounds 93.03. That's the minimum cost for running this. Next part of the question. Prove by using d square c by dv square that the cost is minimized at the speed found in AI. So what it means is we found the cost, but what is the guarantee that it is minimum? It could be maximum because dc by dv is equal to 0 at both maximum as well as minimum. So using d square c by dv square, we can prove that it is minimum. Okay, so what we do is we need to take the dc by dv and differentiate it again. So we say d square c over dv square is equal to, differentiating the first one once again, I get 3000 v to the power of minus 3, and that is equal to 3000 bracket, what was the v value that we found? 90.83. So put 90.83 to the power of minus 3, and the calculator, we don't need to exactly calculate it. We say that 3000 divided by 90.83 to the power of 3. This is always greater than 0. There is no chance of this becoming negative. Therefore, we say that d square c by dv square for this value of v is positive. Then you write as d square c over dv square is greater than 0. It is a minimum value. It's a minimum value for c. That's it. Last part of the question is, state one limitation of this model. You can always expect this 1 mark question in all model related questions in the A and the AS level papers. We just need to write one reasonable critique of the model, one limitation of this model. So in this case, we were talking about a lorry going at a specific speed for a long distance from London to Newcastle. That itself will be an unrealistic proposition. So we can say it's not realistic to drive a truck or a lorry at the same speed for long distances. That is enough to get 1 mark for this question. Question 9. G of x is equal to this. Use the factor theorem to show that x plus 2 is a factor of g of x. So the factor theorem says that if x plus 2 is a factor, then f of minus 2 should be equal to 0. So what we are expected here to do is put g of minus 2 here and check out if this is 0. If that gives us 0, we are done. So let's write out that. So g of minus 2 is equal to 4 bracket minus 2 to the power of 3 minus 12 bracket minus 2 to the power of 2 minus 15 bracket minus 2 plus 50. I just replaced all the x values with minus 2 here. So putting that into calculator, I get 0, okay? Which means I can now write as g of minus 2 is equal to 0. X plus 2 is a factor of g of x. That's as per the factor theorem. Next part of the question, hence show that g of x can be written in the form g of x is equal to x plus 2 times ax plus b to the power of 2, where a and b are integers to be found. Okay, looking closely at this, they have just factorized this, which means I need to find the second factor other than x plus 2. So that can be done only by making a full polynomial division of this expression by x plus 2. So let's try that. So let's write out the full polynomial first. That is 4x cubed minus 12x squared minus 15x plus 50. Okay, putting that into the division mode. Okay. Here we put x plus 2. Okay, so when you divide, you just need to look at this 4x cubed and this x. You don't need to worry about this plus 2. Just look at how many times x goes into 4x cubed. It is 4x square, right? Therefore, multiply 4x square and this whole expression. So 4x cubed plus 8x squared, okay, and put a line and then subtract this out. So this is 0. Minus 12 minus 8 is minus 20 x square minus 15x plus 50. Okay. So the next time what we have to see is how many times x will go into minus 20x square. So minus 20x. That will be minus 20x square minus 20 times 2, 40x. Again subtracting, we get 0 here, but here minus 15 minus of minus 40 will make it plus 25x. Then plus 50. Now x will go into 25x 25 times. So that is 25x here plus 50 here. Obviously, the remainder will be 0 because we know that x plus 2 is a factor. So we can write the g of x is equal to x plus 2 bracket this quotient here 4x square minus 20x plus 25. Okay. Now we need to factorize this second part so that we can write this as a factorized form. So x plus 2 bracket 4 times 25 is 100. So there are two factors of 100 which will add to give you minus 10. So it should be minus 10 and minus 10, right? Therefore 4x square minus 10x plus 25. Okay, so factorize this part and this part. That is equal to x plus 2 bracket, what's common here? 2x. Take out the 2x. So you have got 2x there minus 5 minus 5 bracket 2x minus 5. Okay, right. Why did I write minus here? Because minus 5 times minus 5 will get me plus 25, which is required here. Okay, so this and this are common, so we can take it out. So that is equal to x plus 2 bracket 2x minus 5 bracket 2x minus 5 again. This 2x, this minus 5, which translates to x plus 2 times 2x minus 5 square, which means a is equal to 2 and b is equal to, what did the question say here? Ax plus b, right? So a is equal to 2, b must be equal to minus 5. Okay. So if you write this way also, you'll get full marks there. Next part of the question, figure 2 shows a sketch of the part of the curve with equation y is equal to g of x. Use your answer to part B, where we have found out the factors, and the sketch to deduce the values of x for which g of x is always less than or equal to 0. So here what we need to do is look for the g of x values which are below the x-axis, because this is the y value. Less than 0 means this is the y value which is less than 0. Okay, so what is this point? Since we know that x plus 2 is a factor, this particular point is minus 2, 0, right? Therefore, x should be less than minus 2. If it is more than minus 2, it will get us a positive y value. That's not what we want. We want less than 0. So we can say that g of x is less than or equal to 0 when x is less than minus 2. So we can write that here. CI g of x is less than or equal to 0 when x is less than or equal to minus 2, right? What is this next part of the question? X minus 5. G of 2x is equal to 0. This actually means a transformation where the g of x is translated horizontally. Okay, I mean not translated, transformed horizontally with a stretch value with scale factor of half. That means every x is multiplied by half so that we get g of 2x. So if at all there is an x value here, I need to multiply that by half so that I will get the new g of 2x value. So this should be equal to 0. Again, this actually means that if g of 2x is equal to 0, this curve should come somewhere here. What will be that x value? So we now know that minus 2 has to be multiplied by half. So minus 2 times half will be giving me minus 1. So this is minus 1, 0, at which g of 2x is equal to 0. So we can write g of 2x is equal to 0 when x is equal to minus 2 divided by 2 is equal to minus 1. But not only that, there is another point at which g of x is equal to 0. This point. So we already know that 2x minus 5 is the root. So this point is 2x minus 5 is equal to 0. That means x is equal to 5 over 2. So this particular point is 5 over 2, 0. All right. Now, if I apply the same transformation of 2x to this point, I need to multiply 5 over 2 by half to get 5 over 4. So we need to write here, when x is equal to minus 2 over 2 is equal to minus 1, and x is equal to 5 over 2 times 1 over 2 is equal to 5 over 4. So these are the two x values. So underline them conspicuously so that you get marks. Question 10. Prove from first principles that the derivative of x cubed is 3x square. This is quite a common question which comes in AS level as A level as well as A level. Therefore, it will be very good for the students to please practice with it. It's a sure mark, 4-mark question. It's quite easy to do also. The formula for this is given in the formula sheet. From first principles means we need to write derivative is equal to limit h tending to 0 f of x plus h minus f of x all over h. This formula is given in the formula sheet. What we need to do here is just replace the x plus h with the given y value here. So y is equal to x cubed. This 3x square is the result. This is the starting point for us. So we need to write that is equal to limit h tending to 0. Instead of f of x plus h, just write x plus h to the power of 3 minus f of x is x cubed, okay, all over h. So we need to expand this x plus h whole cubed. For those who have already learned the algebraic identities, it's quite easy. Otherwise, I'll write it here. So it is a plus b whole cubed. Like a binomial expansion, this goes a cubed plus 3a square b plus 3b square a plus b cubed. We just replace a and b with x and h, then you'll get the full expansion like this. So we can write this is x cubed plus 3x square h plus 3h square x plus the last term is h cubed minus x cubed. There's no change for that. And then denominator is h. Okay, simplifying this, we will be getting limit h tending to 0. Remember to write limit h tending to 0 in every step. Otherwise, mathematically it is incorrect because we are finding the limit. Now, when I expand this, I get this x cubed and the minus x cubed gone. So therefore, 3x square h plus 3h square x plus h cubed all over h. Okay, that is equal to limit h tending to 0 once again. Let me factorize out the h here because every term contains a h. So this is 3x square plus 3hx, okay, plus h square. Close the bracket, h here. Now cancel out this h and h. So finally we get limit h tending to 0, 3x square plus 3hx plus h square. What this means is when h actually becomes 0 or quite close to 0, we can ignore all the h values. So at that time, we write dy by dx. Only in the last step, we write dy by dx. When we write dy by dx, we can drop this limit h tending to 0 because we are taking effect of h being equal to 0. So that is equal to 3x square because this term and this term will disappear. So this is the final answer. Question 11. Find the first three terms in ascending powers of x of the binomial expansion of 2 minus x over 16 to the power of 9, giving each term in its simplest form. So we just need first three terms. Another thing, the binomial expansion of this when the index is a positive integer 9 is the year 1 binomial expansion calculation. So that formula will be given in the formula sheet. Anyway, I'll write it here. It's like this. Suppose it is a plus b to the power of n. The first term will be a to the power of n. Second term will be nc1, a to the power of n minus 1, b to the power of 1, plus nc2, a to the power of n minus 2, b to the power of 2, and so on. And there is a general term, that is ncr, a to the power of n minus r, b to the power of r. It's worthy to remember this general term. And the last term is b to the power of the full power of n here. So this is the binomial expansion formula in case n is a positive integer. So since here n is equal to 9, let's use that. So this question is 2 minus x over 16 to the power of 9. So carefully put these values there. Just replace a with 2 and b with minus x over 16. That's it. So that is 2 to the power of 9 plus n, which is 9 again, 9c1, 2 to the power of 9 minus 1 is 8, bracket, minus x over 16 to the power of 1, plus nc2, which is 9c2, 2 to the power of 9 minus 2, which is 7, minus x over 16 to the power of 2, plus dot dot dot. We only need three terms. So first term, second term, third term. Putting into the calculator, I get the first term as 512 plus 9 times 256 times minus x over 16 plus 9c2 is 36 times 128 times x square over 256 plus dot dot dot. Okay, that simplifies to 512 minus 144x plus 18 x square plus dot dot dot. So this is in ascending powers of x, and that's the answer for the first question. Second part of the question is f of x is equal to a plus bx times 2 minus x over 16 to the power of 9, where a and b are constants. Given that the first two terms in ascending powers of x in the series expansion of this f of x are 128 and 36x. So what the question tells you is, if the whole thing is expanded, you get 128 and 36x. Therefore, find the value of a, find the value of b. So we already know the first expansion of 2 minus x over 16 to the power of 9. So what the question further says is, if we put a plus bx times that, you get 128 and 36x. So you need to actually read through and derive what's the value of a. Let's do one thing. So the question says that a plus bx, okay, bracket 2 minus x over 16 to the power of 9. Okay, this is equal to f of x. Okay, and that gives us 128 plus 36x, the first two terms. So what we need to do here is, which terms will produce this constant 128? A times, a is a constant here, a times the expansion of the second one with a constant term there, and that constant term is 512. So which automatically means 512 times a should be equal to 128, right? So that means a is equal to 128 over 512, which is 1/4. Done. So a part is done. Now how to derive b value? B is actually the coefficient of x here, and that gives us 36x when you multiply b of x with something inside here, which will only give the x term, not x squared term. So which terms will produce x? Bx times 512 will produce an x term, and a times another x term coming out of here will also produce the x term. So we can write x terms are a times this, all right, and bx times this. So let's write bx times 512, that's one x term, so plus a times an x term coming from here, and that x term is minus 144x. Okay, both together is equal to 36x. Okay, so now we can comfortably cancel the x from each of them. So we can now write 512b minus 144a is equal to 36. Since we already know a, we can solve for b from here. So we get 512b is equal to 36 plus 144 times 1 over 4, which is equal to 36 add 4 goes into this 3 times, and in 24 it goes 6 times. So that is equal to 72. Therefore, b should be equal to 72 divided by 512, which gives us 9 over 64. That's it. Underline the two values. So a is equal to 1/4 and b is equal to 9 over 64. Question 12. Show that the equation 4 cos theta minus 1 equals 2 sin theta tan theta can be written in the form 6 cos square theta minus cos theta minus 2 is equal to 0. So we need to do some trigonometric identities here, rearrange them, and make it as a quadratic in the form of cos square theta minus cos theta, etc. So obviously we need to get rid of the sin theta here, get rid of the tan theta here. So let's write out the first equation, 12a. So the equation is 4 cos theta minus 1 is equal to 2 sin theta tan theta. Okay, so we finally should get an equation in cos square theta, right? So please focus on how to remove the sin theta and tan theta. So first let's write 4 cos theta minus 1 is equal to 2 sin theta times tan theta can be written as sin theta over cos theta. Okay, now multiply everything by cos theta. Okay, what happens here is 4 cos square theta minus cos theta is equal to, this cos theta will disappear when you multiply by cos theta, leaving 2 sin square theta in the numerator, okay, which can be written as 2 times 1 minus cos square theta. So we can write this as 4 cos square theta minus cos theta is equal to 2 bracket 1 minus cos square theta. Okay, that means 4 cos square theta. Okay, then we got a minus 2 cos square theta over there, which will add up with this 2 cos square theta, okay, minus cos theta. Okay, and then there is a 2 times 1 there, which is minus 2 here, is equal to 0. Let's look at the equation once again. Okay, now we can simplify this to 6 cos square theta minus cos theta minus 2 is equal to 0 is what the question wants you to arrive at. B part. Hence solve for x being greater than or equal to 0 and less than 90 degrees. 4 cos 3x minus 1 is equal to 2 sin 3x tan 3x. So what we need to do in such questions is compare, because it says hence. So whatever we have done in the previous part of the question, we can use it in this part. So 4 cos 3x is 4 cos theta and 4 cos 3x here. So the only change is theta has become 3x. Similarly here, 2 sine theta tan theta has become 2 sine 3x tan 3x. So theta is equal to 3x, which means if I replace theta with 3x in this equation, that will be the same as this. And then we will be able to solve using this quadratic. So let's change all the thetas into 3x and rewrite. So this is going to be the B part. I'm going to write this as 6 cos square 3x minus cos 3x minus 2 is equal to 0. This is a quadratic in cos 3x. So suppose I write, for convenience sake, let cos 3x is equal to t. Then this will become 6t square minus 1t minus 2 is equal to 0. Right? That means I can write this as 6t square minus 4t plus 3t minus 2 is equal to 0. Because when I add minus 4 and plus 3, I get minus 1. When I multiply minus 4 and 3, I get minus 12, which is 6 times minus 2. So if I factorize this, I have 2t times 3t minus 2 plus 3t minus 2 is equal to 0. Therefore, 2t plus 1 bracket 3t minus 2 is equal to 0. Hence, t should be equal to minus 1 over 2, or t should be equal to 2 over 3. Since we have already assumed that t is equal to cos 3x, these values are for cos 3x. So therefore, cos 3x is equal to minus 1 over 2, or cos 3x is equal to 2 over 3. Okay. Therefore, 3x will be equal to cos inverse of minus 1 over 2. Putting into the calculator, I get 3x is equal to 120 degrees. Okay. And putting into calculator here, cos inverse of 2 over 3, I get 48.19 degrees. So these two are the principal values. So, but that's not the end of it, because we need to solve it between 0 and 90 degrees. So what we need to write here is, the original limits were 0 and 90 degrees. Okay, I'm going to change this into 3x. So therefore 3 times 0 is 0 and 3 times 90 is 270 degrees. So I need to solve for 3x between these two new values. So let's first of all draw the 4-quadrant diagram. So when cos of an angle is negative, see, cos 3x is equal to minus half. If it is negative, the angle should lie where? Okay, so angle cannot lie here or here because they are cos positives. So it has to be here and here. Okay, and the angle is 120 degrees. That's what we calculated. So this is 0, this is 90, this is 180, 270. Right? So let's look for all angles of 3x which satisfy between 0 and 270. So first angle is 120. Second angle is, if this is 120, this is 60. Okay? And this is 60. Therefore, 180 plus 60 is 240. Okay? So 3x can be equal to this, leading to x is equal to 120 divided by 3, 40 degrees. And 240 divided by 3 is equal to 80 degrees. So park it there. Let's come back to the second value of cos 3x. So cos 3x is equal to 48.19, and the cos of the angle is positive. Therefore, let's draw the quadrant diagram once again. Oops. Okay, so this time cos is in the positive region, here and here. These are the two quadrants where cos is positive. So we calculated that this is 48.19 and this is also 48.19. And going for scouting for the angles, this is 0 degrees, 90 degrees, 180 and 270. We are only interested in angles which are falling between 0 and 270 degrees as per this. So the first angle is 3x is equal to 48.19. Okay. The second angle, there is no other angle between 0 and 270. So that's it. So we can now figure out that x is equal to 48.19 over 3 is equal to 16.06 or 16.1 degrees. Now putting them all together, so x can be going in chronological order, size order, 6.1 degrees, 16.1 degrees, 40 degrees, and 80 degrees. These are the three possible angles. Question 13. The value of a rare painting, pounds V, is modeled by the equation V is equal to PQ to the power of T, where P and Q are constants and T is the number of years since the value of the painting was first recorded on 1st January 1980. The line L shown in figure illustrates the linear relationship between T on the x-axis and log V to the base 10 on the y-axis since 1st January 1980. The equation of line L is given here. Okay. Find to four significant figures the value of P and the value of Q. It's quite easy here. What we need to do is, first we need to write the equation given there. V is equal to PQ to the power of T. Okay. Suppose I take logarithm on both sides. So then log V to the base 10 is equal to log P to the base 10 plus log Q to the power of T to the base 10, which can be rewritten as log P to the base 10 plus T log Q to the base 10. Now compare this with the equation given in the question. The equation given in the question is log V to the base 10 is equal to 0.05 T plus 4.8. Comparing, we now know 4.8 is equal to log P to the base 10. 0.05 is the gradient, which is the coefficient of T. So that is equal to log Q to the base 10. And log V to the base 10 remains there on the y-axis. That's not a problem. So this is enough information for us just to find the value of P and Q. So let's write. So 4.8 is equal to log P to the base 10. Right? That means P should be equal to what? You just need to write 4.8 there as an index. So this base goes to the other side, 10, and the 4.8 becomes the power. Okay. The question says to four significant figures. So we need to convert that into value from the calculator. This is equal to 63,095.9.73, okay, which actually translates to, if I put it into four significant figures, 63,100 underline. Okay. Similarly, 0.05 is equal to log Q to the base 10, which means Q should be equal to, bring the base to the other side and put 0.05 as the power. That gives us 1.122. That's it. Next part of the question. With reference to the model, interpret the value of the constant P and the value of the constant Q. Okay, so here we need to write one more question each. The interpretation of the value of constant P. What does constant P mean? So we need to write here as B. Okay. The value of the painting. P represents the original value, right? Represents the value of the painting on the starting date 1st January 1980. Okay. And Q represents the rate of increase in the value every year. It's like a compounding, increasing the value each year. Next part of the question, find the value of the painting as predicted by the model on 1st January 2010, giving your answer to the nearest 100,000 pounds. So be careful here. Okay. Now, 1st January 2010 means compare this with 1980. So it is 20 plus 10, 30 years. So we just need to put t is equal to 30 in the model. That's it. So let's write out. So C V is equal to, we already found out p value, so we can use that, 63,100 times, we also know the q value, which is 1.122, right? 1.122 to the power of 30, because t is equal to 30 here, and that gives us from the calculator 1,994,412. Okay, but the question says round it to the nearest 100,000 pounds. So if you round it to the nearest 100,000 pounds, you get 2 million. Cool, that's it. Question 14. The circle C has equation x square plus y square minus 6x plus 10y plus 9 is equal to 0. Find the coordinates of the center of C and find the radius of C. Okay, so this is also a style of writing the equation of a circle. Only thing is we need to convert that into our usual form to find the radius as well as the center. So what we do is completing the square. So the equation is x square. So collect all the x terms first. X square minus 6x plus y square minus 10y plus 9 is equal to 0. So completing the square, we get x minus 3 square minus 9 plus y minus 5 square minus 25 plus 9 is equal to 0. We subtract this 9 and this 25 as square of 3 and 5 because they are not there in the original equation, right? Okay, that's equal to x minus 3 square plus y minus 5 square minus. This minus 9 and plus 9 get cancelled. So we got minus 25. So minus 25 is equal to 0 can be written as equal to 25. So this is our usual form of a circle equation from which we can easily derive what is the center. So write center is equal to 3, 5. Is this plus or minus? This is plus 10y. Therefore, this is plus here. Therefore, this is plus here. Therefore, this is minus here. Okay. So the center is 3 minus 5 and radius is equal to square root of 25, 5. Okay. Underline the answers. The line with the equation y is equal to kx, where k is a constant, cuts the C at 2 distinct points. That means the line should pass through the circle, not as a tangent. So find the range of values of k. All right. So y is equal to kx means if I substitute y is equal to kx in this equation of the circle, then I will get a quadratic. And then since the question says that there are 2 meeting points, I can then say that b square minus 4ac should be greater than 0 and then solve for k, right? Let's use that strategy here. So b part, we are going to replace all the y's with kx. Okay, so x square minus 6x plus kx square plus 10 bracket kx plus 9 is equal to 0. What I did is I replaced all the y's with kx. Okay, so now a little bit of work is here. So x square minus 6x plus k square x square plus 10kx plus 9 is equal to 0. Now I need to make this a quadratic in x. Therefore, collect all the x square terms. This is x square 1 plus k square. Okay, so this and this are done. Then I need to collect all the x terms. So put plus x bracket. I got 1 minus 6 here and plus 10k here. So 10k minus 6. Okay, this and this are also done. So what remains is plus 9 is equal to 0. Okay, so looking at this equation, we can easily write A is equal to 1 plus k square. B is equal to 10k minus 6. And C is equal to 9. So if I write b square minus 4ac should be greater than 0. If I replace them, b square will be equal to what? 10k minus 6 square minus 4 bracket 1 plus k square times c is what? 9 should be greater than 0. So this is leading to another quadratic now. That's fine. We can solve for k from here. So 100k square minus 2 times 6 times 10 is 120k. Okay. Then plus 36. Then minus 4 and 9 make 36. 36 times 1, 36 here. Then again minus sign, 36 times k square. Okay, should be greater than 0. Right. So this plus 36 and minus 36 go away nicely. So we have got 100k square minus 36k square, which is 64k square. So I am underlining this so that I have taken care of them. Now I got minus 120k, that's also done, is greater than 0. Okay, this means if I factorize this, what's common here? 4k goes into both terms, so I will take out the 4k, that is 16k here, minus 30 is greater than 0. Okay, checking out 64k square minus 120k. Okay, all right. Therefore, the critical values of k are k can be equal to 0 because 4k times something is 0, or k should be equal to 30 over 16. Okay. 30 over 16, which is equal to 15 over 8. So these are the two values of k that will satisfy the required condition there. Since this is an inequality, so we have now found out the critical values, right? K is equal to 0 and k is equal to 15 over 8. Now, in all inequality questions, we should draw a sketch of that quadratic to figure out what is the exact value of k or the range of values of k. So this is k is equal to 0, so one root is here. K is equal to 15 over 8, so another root is here. Okay, right. So the equation of the curve is like this. The curve will be like this because 64k square is positive, so it's not like this, it's like this. Okay, right. Therefore, we want greater than 0, right? Therefore, all the values of y which are greater than 0 are what we are interested in. Therefore, k should be less than 0 or k should be greater than 15 over 8. So we have to write these two inequalities to actually get the full marks for the question. Critical values won't give you the marks. You need to actually say, since this is an inequality, k has to be greater than 15 over 8 or less than 0. Question 15. Figure 4 shows a sketch of part of the curve C with equation y is equal to 32 over x square plus 3x minus 8, where x is always greater than 0. Right. The point P4, 6 lies on C. Okay, so let's write this point as 4, 6. Okay. Line L is the normal to C at the point P. So this is normal. Okay, right. The region R shown shaded in figure 4 is bounded by the line L, the curve C, and line with equation x is equal to 2 and the x-axis. All right. Okay, that's R. Show that the area of R is 46. So this is a show that question. So the answer is given to you. So you will know at the end whether your answer is correct or not. So we need to show that this is 46. So what's the strategy here? Since this shape is in this way, we won't be able to get the area in one go by integrating it between 2 and this value. So we need to devise another strategy. So put a line here. Okay, so this is equal to the x coordinate of P, so this is 4. So if I integrate the equation of the curve between 2 and 4, I will get this area. Then I only need to find the area of this triangle and then add to this, so that the total area of R can be obtained. So to get the area of this triangle, I need to find the height of the triangle, which is not a problem because the y coordinate of P is its height. But the x coordinate of this point has to be figured out so that I can find the base value. That is 4 up to this is what? So in order to get this, so let's focus on this task now, how to get the intercept value for the normal with the x-axis. So for that, we need to get the equation of the normal. To get the equation of the normal, we need to get its gradient. To get the equation of the gradient or the gradient value, we need to get the gradient of the tangent, which is equal to the gradient of the curve. So starting from dy by dx of the curve, we get the gradient of the tangent, then we get gradient of the normal, and then we write the equation. Okay, so let's use that strategy. So first and foremost, equation of the normal. So any equation in the world is in this form: y is equal to mx plus c, where c is the y-intercept, m is the gradient. So in order to find the gradient, we need to find first of all dy by dx of the curve, right? So y is equal to 32 x to the power of minus 2 plus 3x minus 8. That's the equation of the curve. So I need to just differentiate this with respect to x. That is minus 64x to the power of minus 3 plus 3. All right. So dy by dx is this. Now, to get the numerical value of the gradient, which is m, we write at 4, 6. Okay. Dy by dx is equal to minus 64, 4 to the power of minus 3 plus 3. And putting that into the calculator, I get this value as 2. So this 2 is the gradient of the tangent. Okay, so we can write here tangent gradient is equal to 2. Therefore, normal gradient will be equal to the negative reciprocal of the 2, that is equal to minus 1 over 2. Therefore, the equation of the normal will be y is equal to minus 1 over 2 x plus c. So we still need to find the c value. So, but we can use 4, 6 here. So at 0.4, 6, okay, 6 is the y value. So write 6 is equal to minus 1 over 2 bracket 4 plus c, which is 6 plus this 2 cancels this 4 to 2 with a minus 2 adds to this 6 to form 6 plus 2 here is equal to c is equal to 8. Okay, so cool. That means the normal is y is equal to minus half of x plus 8. Okay, then to find the x-intercept, okay, we can say at x-intercept y is equal to 0, right? So this 0 is equal to minus half of x add 8. Therefore, 8 is equal to half of x, leading to x is equal to 16. So that's a very important information for us. So we can mark this point as 16, 0. Therefore, area of the triangle is quite easy now to find. And then area of this region under the curve is integration. Right. So now let's write out what we are planning to do here. So area of R is equal to area of the curve, which is integral between 2 and 4 of f of x, okay, plus f of x dx plus area of the triangle. Okay. So let's now find the first part of it. Integral between 2 and 4. What was the equation of the curve? 32 x to the power of minus 2 plus 3x minus 8 dx. Okay. Integrating this, start with putting square brackets. So 32 x to the power of minus 1 over minus 1 plus 3x square over 2 minus 8x, and between the limits 2 and 4. That simplifies to, let's now evaluate it. So bracket minus 32 x to the power of minus 1 is 4 to the power of minus 1. So you can divide by 4. Okay, plus 3 bracket x square is 16 divided by 2 minus 8 times 4 is 32. Close the bracket minus. Let's now put x is equal to 2 and do the same thing. So minus 32 over 2, because 2 to the power of minus 1 is division by 2, plus 3 bracket 4 over 2 minus 8 times 2, 16. Right. Putting this into the calculator, I get this as 10. Okay. That means area under the curve, let's say. Okay. Now let's find out the area of the triangle. Area of triangle is equal to half times base times height. So we know half times base was 16 minus 2 or 4, because the second value of the x. So 16 minus 4 times the height is 6. That is equal to half times 12 times 6, which is equal to 6 times 6, 36. Okay. Therefore, overall area of R is equal to 10 add 36 is equal to 46, which is what the question asked us to prove. That's done. Okay, that's the last question. Well done. Therefore, thank you very much for walking through with me. So let's now focus on the next in the series of past papers in AS level and A level. All the best. Take care and thank you.